people can tell from the title, we are going to talk with Spurskimo about Vantage Point. Now, let's try to get him. Whoa, got some viewers. Let's go over to the chat.
Good evening.
Actually, it is evening over here. Good.
Well, it's late. It's about 10 o'clock for us.
Yeah, 5:15 here.
So the moon has gone for you.
No, the moon is in a position. It's in a position where it is viewable.
But is it a
by
full
two
moon?
different observers?
Is it a full moon?
An angle, it would be the same for either person. So people can understand what we're looking at, I'm going to share my screen. See the image that is in question. Wow, that looks weird on this end. Let's see how it looks on the live side.
It's flashing.
That's what I'm trying to figure out why.
Just give me the two addresses. The two addresses. Is that Florida, Texas? Is it?
No. This is I pulled up a road I live that
where is it though? Tell me where it is.
This is, as you can see this town here, Framingham.
Framingham. Okay, hold on.
In Massachusetts. The road right here, that is the red line, is State Route 9. East to west.
Framingham, Massachusetts, USA. Yep. Okay.
So
where?
No, it's one road.
No, where's the other place that you've got it going to?
No. If you pull up where the Natick Mall is, it's the main road right in front of that mall. Very small scale because it's a proof of concept that you continually miss.
So you've got it from. Hold on, I need to find where you're looking.
It's on the screen.
Yes, but I'm trying to find it on my one. I've got it here also. So you've gone across the river. Okay, yeah, I found that road. 135, yes?
No. It's Route 9.
Route 9.
You go north of that.
No.
So Route 135 is a small road going through the middle of Framingham. You go north of that towards where Framingham State University is.
Right, so I see.
Over here, this is Route 9. Right over here. You can see right there. 9.
No, make yours a satellite. I'm looking at a satellite image. Make it a satellite image.
This is in Paint. It's not in. I can go over to Google and might frizz out.
All right, I'm gonna try and find what you've got. Okay. Oh yeah, I see that. No, I can see it. I can see it. Yep. Okay, I found it. Yes, I found it. 30.
So
Yes.
the 30 Route 9. So that road
Yeah, Route 9. I found it. Yeah.
so that
Minardo. Hmm.
goes east to west.
Hmm.
General direction. It has its curves, but that is the direction of this highway. Savvy?
Yep.
So what I went ahead and did was put the cardinal directions on here for you. South down here, east over here, because if you keep following this road in that direction, you're going to end up in Boston, Massachusetts.
Mm-hmm.
Is west. So again, small scale because this is showing the concept. So this red dot with this arrow and this line, direction of travel for a vehicle on that road going from west to east.
Mm-hmm.
For the ISS. Savvy?
No, you're just choosing a random path now for where the
No, I'm not.
ISS.
No, I'm not. The
What are you
ISS
doing?
it's a proof of concept.
Go on, and let's just finish it now.
Because you keep saying that red's footage direction by cardinal direction than the Texas footage. Correct.
Yeah, that's right.
Here's why. So you are standing at this green dot number 1. You are looking south to the road. Follow a car. What direction relative to you is that car going?
Right to left.
Which corresponds to what cardinal directions?
East to west.
No. If it's going right to left,
if I'm south.
No, you are north of the path.
Sorry, then
you are
not.
at dot 1.
Oh,
right here at the mall.
Yes, I'm at 1. So cars are going right to left. Yes, west to east. Mm-hmm.
Correct. Now, you have a friend over here at dot 2.
Mm-hmm.
What direction are they seeing?
Right. They're seeing the cars going right to left now, yes? East to west.
No. The car is still moving from this dot
west
here.
To east. Sorry, west to east. Yes, west to east.
It is still going west to east. But
yes.
But visually from spot 2, what direction is it going? In reference to the observer.
He's seeing the cars going from left to right.
Yet it's still going the same direction.
Yeah. What's the problem? I'm not. This doesn't confuse me. This problem.
This is exactly what you're seeing between the footage taken in Texas and taken from Red in Florida. Mind you, they are a month apart. So the actual stop. So the actual part, it is not the same transit, which means it's not the same exact path of the ISS. There has been a deviation there. Part 2, when the observer in Texas was looking slightly more south, analogous to this view, number 1, transit. Red was looking directly west, which put the bottom of his field of view, camera frame, looking straight west. So as the ISS was moving from southwest towards the northeast, it would look like it's going from the bottom left in frame.
Yeah, that would make sense if the moon.
That is actually what happened. This setup right here is exactly why visually observations appear to you to move in opposite directions. Did not.
No. Well, let me explain then. Can I have a go?
Go for it.
Okay. So stop your screen then. I'm going to share my screen. This is the problem that you're facing, right? You're putting the moon and the ISS relative, right next to each other, just above the Earth here. So we've got the moon.
No, they're in line with each other, not next to each other.
We've got the moon.
And
hold on.
it is no different than you watching behind a tree on the other side of the highway. Are they next to each other, or are they passing in front of each other?
Why is that not fitting? No, it's a huge difference, right? I can tell you why it's a huge difference. Right, the moon's much smaller than the Earth. Right. This is why your road, right, that you were trying to show me, that you said on this side of the road, that side of the road, is only here. No. This is when you get that kind of phenomena, what you're talking about. Everybody in the north, at this time, this is the point that all of you borders are missing, because you want to try and place the moon. And even if you place the moon anywhere, any place, you're still going to, from this distance, you're still going to get the same thing, because the line of sight is so small from the Earth. And look, this moon, well, let me just show you, look. So from Texas, looking there, let's change the color line. Let's make that red. That one. That one. Okay, so now we've got red. They're looking, look at that. Look at the line. And look, this is short, what I'm showing you here. So that line touches, right? So the observers, it doesn't matter where they are and they are. They'd have to cross here to see that upside down, change position, whatever you want to call, go backwards, go different directions, whatever you want to call it. And obviously this isn't to scale, okay? So are you still there?
Yeah, I'm still here.
Yeah. So obviously this isn't to scale. The moon is much, much further out there. So that makes this line even more closer together, much more thinner. The line, the two observers are looking at something and it meets, the line joins very, very thinly. So if you had an observer, obviously from here, you would say, oh, look at that big gap. Of course, they're going to have different results and blah, blah, blah. I would accept that. But because this is all that does it for me.
So,
him,
so a distance of about 1,500 miles, insignificant distance to you?
No, look at the gap, the angle there, the gap here between the two observers. There's nothing, absolutely zero in terms of where the moon, and you're trying to put the moon right here. So like I said, you have you're trying to make the angle like this. So it's such a, yes, that's what you're trying to do. You're trying to put the road here.
Okay.
Yeah, go on.
Do you know how to triangle?
No, you're not going to try and catch me out of all these kind of things, all that kind of stuff yet. Now, I understand it very well. Look, Jared, I understand it very well. If this moon was even further away, that line, look at this red line and this black line. So it doesn't, this is what I'm saying. You guys, this is the problem you're going to have. Red's transit came one way. We saw the other guy's transit so red's, sorry. I know, look, I understand that you have to explain it away somehow, but red's transit, he saw, to look into this moon, he saw it going against the Earth, around past the moon, or what? Going up, he saw it going up. No, look, stop. This is the point. This is what I'm saying.
Saw it go from south of west.
When red
to
is red,
north.
look, you are the look. If red is looking up at the moon, his right shoulder is on this side. Yes, his left shoulder is on this side. So that means when he looks up, the moon is moving that way. The same thing happened for the guy in Texas. The moon moved that way. So there's no difference. This is why I don't understand why you guys don't understand that. The moon, for both observers, moved this way. Whether it moved that way, it still moved to the right around this ball to come back around and then back round again. That's what it did. All it did was change. All it did was change like a clock, like 9 o'clock, 8 o'clock. So,
what cardinal direction was the gentleman in Texas facing?
the same as red. Exactly the same as red. Look, if you were to drive, if you were in Florida and you drove,
hang on,
go on.
The guy in Texas was looking directly west.
West. Here's west. West.
Where it was, I was asking which direction the observation in Texas was taken.
They can only look west.
No.
Well, where can you put the moon then? All right, then show me where you want to put the moon to satisfy it. Where should I put the moon? Where can I put this moon to satisfy you? That red saw it in a different position, and where shall I put the moon?
Stop moving the mouse. Stop. 3 inches.
Where? Which way?
Down 3 inches.
There, down.
Stop. Now go right about 6 inches. Keep going. Keep going. Keep going. Keep going. Keep going.
Ah, you see? You see?
Keep going. You lost to reality. Keep going.
What are you talking about?
For this view of the Earth that you have, where the moon was at the time of both observances.
So you're going to tell me
the moon would be between where we are currently looking at this image,
like this,
slightly left.
Doesn't matter. It's got to move.
Yes, it does. Stop.
Here?
Right, half the width of the moon.
Sorry? You want me to place it here?
Right, half the width of that object. Stop there.
Okay.
Now, with the moon in that relative position to as we are looking at the Earth, with the moon between us and the two observers.
Yeah.
West.
Looking west.
The guy in Texas would be looking south.
No, they're looking straight at the moon, both of them, and that's what I'm saying. You've got
and when Red got his observation, the moon was close to the horizon, west. When the guy in Texas got his observation, it was the middle of the night with the moon relatively overhead. When we go back,
it doesn't.
Yes, it doesn't. Yes, it does matter.
No, it doesn't matter because look,
orientation and vantage point matters.
No, it wouldn't matter because if they're both looking at the same thing still,
it's amazing how you can get it when it was a car down a street, but as soon as it's a celestial object, your cognitive
because look what you've done. You've brought the moon right on top of the Earth to make it work.
No, it's not on top of the Earth. It's between us and the Earth.
So
we want to be accurate.
We put one observer.
If you really want to be accurate about it, that's what we got to do.
Look, one observer there. Okay, looking there. And the other observer. Still, what's the difference?
Yeah, there's still a huge difference.
They still meet. Yeah, by the time this reaches the...
They still meet at the moon, but one is looking west, the other is looking overhead.
Do you know how many miles is between this point and this point? you understand how many miles?
On the Earth between Texas and Florida?
The miles are important because it's like you're saying you can step from one side of a star to the other side of a star. How could you? That's ridiculous to think like that. You can't say I can walk and see. You
Physical
can't say
step, no. But here's the thing: when you're looking at something in the relative neighborhood, moon, between the Earth and the moon, a movement of 100 miles is going to result in a change in the observation. So, what do you think?
No. I disagree. I disagree with. That's my point. That's my contention. I disagree that at
do we need to draw a triangle for you?
At this distance,
do we need to draw a basic triangle for you?
If you're saying this, then you're saying that the moon is close, like we say in the flat Earth.
No, I'm saying the moon is between the Earth and us as we are looking at it in this image.
Draw me a scale, Earth and moon.
I have an image large, a screen large enough to do that, to where things can be seen.
No, just make the exactly my point. If you put two dots, listen. If you'd made two dots, home is limited. If you made two dots and one dot just a bit bigger than the other dot, and then draw two lines like a line of sight, because line of sight doesn't matter who the observer is. Could be like an ant, could be an amoeba, could be a giant. You know, it doesn't matter who's looking. The line of sight stays the same. So if you did it to scale, you would get even worse results because the line would be so small, you wouldn't be able to
get a difference when you actually apply it to reality. See, that's the thing with scales is physics of it.
Let me give you something. Let me give you something here. Look, show you exactly what I'm talking about. These two lines meet. So if you were to make this smaller and smaller and smaller, you've got no chance. None at all. It's like one line, Jared. One line.
You can't even understand a basic triangle. Yeah, there is no chance for you.
Look, I'm proving it without a doubt. And this is why you kicked Ali out. You know,
no, he gets kicked out because he doesn't want to listen. He asks a question, and then as you're starting to answer, he talks over you because he doesn't want the answer. That's why he gets kicked out of places. It's not an informational issue.
Seriously, you've just helped me to realize something. He's got no chance. Absolutely no chance.
Here's the thing, though. I gave you a proof of concept on where your failing is that you completely agreed with. But then as soon as it went to a celestial body...
No, I understand that concept. People have been saying that for days.
So why is the concept acceptable on a road with a car, but not in orbit?
Because it only works at the equator.
No, it does.
It's the only chance
it does not only work at
because when you put the moon on the other side of the Earth, you get different results.
I'm gonna have fun with this.
That's what you expect.
I'm gonna have fun with this one.
I can show you a video in South Africa where it goes the opposite way to the guy in Texas, like completely opposite, straight opposite. So Texas goes straight across the screen. And the guy in South Africa goes,
of how you're looking matters.
You keep on saying that, but again, it doesn't help you saying that because look, the line is it just makes if the line is like.
All right, hang on. I just brought up the tracker. Look at something. So stop presenting you.
Wait till I show Ali this one here, yeah. He's not going to stop.
That. Present to everyone. Right, you can see my screen now, correct?
Yeah, I'm looking.
Oh. When you have someone on one side of this line of travel, are they going to see it move in the exact same direction for their field of view? Is up here looking south.
This is Australia and South America, yeah?
No, I'm looking over here in the continental US.
I can't see your mouse. Where is it? Oh, let me stop my screen.
Let's do it that way.
I should stop my.
And present to everyone. There we go. All right, there.
Okay,
now you
I can see it. Yeah.
Okay. Standing at that point there at the tip of the mouse, you are north of the ISS. In order to see a transit, you would be looking generally south. Now, if you have someone over here at the same time, to watch the same transit, they are looking west.
Right, I agree. But check this out, though, Jared. Check this out. Listen.
Okay, yeah. So then you have someone here in Texas.
Yeah.
Over here and down in Florida. You have another 90-degree change servers.
Can I just
why would you accept it up here but not down here?
Let me explain.
Why would you
Okay, well let me explain. Right? Because
why would you accept
you see where you go back to where your mouse was? No, go back.
On this.
Jared, go back to where you just was. Right, stop. So the ISS, you've got to remember something. Your face, listen to me, your face now looking at Earth, looking at the ISS is the moon. Your face is the moon. So when the ISS goes past Texas, put your mouse on Texas, right?
Texas is roughly here.
Yeah. So now he's looking at you, right?
Which would put the bottom of his, if he is looking at me with the ISS going in front of me, if he is north of this line.
No, if he's looking at you right. Stop. If he's looking at you right now, you're up, you're the moon, you're the face of the moon looking down on this guy.
Yes. Yes, he is looking overhead.
No, he's looking straight at you.
Up into the sky, which would be overhead.
Exactly, and that doesn't happen. Exactly, Jad, that doesn't happen. You don't catch the moon over your head. You
don't look up to see the moon.
Let me finish.
You don't look up to see the moon.
Listen, you can catch the ISS.
The problem with up and down again.
You can catch the ISS.
Garden shit again.
No, just calm down. Calm down. Listen to what I'm saying. I'm not disagreeing with anything of what you're saying. The only disagreement I have is that to line it up with the moon, it has to be on special days, special occasions, special times, or whatever. So, yes, the person north and south of that line will get different results. But if they're looking
at
the moon,
exactly what happened between and red. Where's the issue?
No, because if red was to look up at that line, he wouldn't get it past the moon. That's the whole point. If you're saying that he has to look in a different direction.
That's why it took a month. Red's observation was at the beginning of November. His observation was at the beginning of December. They were not on the same day.
No, they were different months, yeah.
Matters. See how much deviation there is just between these three passes?
Oh, hold on. Yes. So listen, imagine this now then. Look, who was first? Red in November, yeah?
Red. Right. He was looking directly west at the moon right before sunrise.
Look, let's say that the last...
He was looking in this direction.
Let's say that yellow line.
In this direction.
Okay, but look, this yellow line...
from here. So he was looking in this direction. This direction. What direction in the field of view? Assess.
So where was Texas looking?
Texas would be looking this way.
Yeah, and where's the moon?
90 degrees off.
Where's the moon?
You said we are the moon as we're looking at this.
So the moon's just moved left.
The moon is at such a distance. No,
you've made a huge mistake.
The moon is at such a distance.
David, you're helping
Here's the
me
thing,
more.
You are still sticking to both of them seeing the same pass against the ISS against the moon.
You've just said
the
that
same date
because red was first. That means the moon
Red
should
was
have moved right, not left
the
at this
moon.
point.
No, the moon.
Yes,
To
but the
Red's
moon moved
position.
right.
Stop. Relative
Go on.
to Red's position during his observation, moving down.
What's moving down?
The moon was moving down.
Yeah, but it's moving to the right against the Earth's rotation, yeah?
Yes, but seeing as how Red was looking in this direction,
Yeah.
the relative field of view motion that Red caught.
So show me the moon's path then from Texas Red to Texas, what you think it is. Put your mouse where Red was looking with
So
the moon.
Red was here.
Yeah. Moon was where?
Red on the moon. It was out in this direction because
no,
the
he
moon
wasn't.
was
He was looking
setting
directly at the moon. That's the problem again. He's
to
the
west.
So how do you make that happen then on the
Listen.
moon? How do you map that? How do you show the
It's
moon?
a big fucking ball.
I'm saying how, Gemma, how do you show that the moon directly from the sky in this position? How do you show Red looking at the moon to the west? How are you going to show that? How are you going to position the moon like that?
So if you really, you know what, go ahead and pull up. Let's do it. I'll have you do it. Now, keep in mind, this is only going to be accurate for Reds.
No, because you're making the moon
not
go
the guy
back.
in Texas. No.
You have.
Ahead,
you're making the moon go back to the left, and it doesn't do that.
Pull up your image again.
If in November.
Stop. Pull up your image again.
Which one? With the compass?
Yes.
Okay. 1 sec. Right. Let's get rid of some of these lines.
All right, go ahead and zoom out.
This is my illustration. But look, at this distance, the line is just like one line. But anyway,
we're ignoring that right now. You want to see how looking at where the moon would be. All right, the compass in the Earth.
You're privy to see this first. I didn't want to show this compass on Earth.
No, so go ahead and select all of it.
What do you want me to do?
Rotate it 90 degrees to the right.
Okay. So rotate right. Yep.
So now that just put west as up. Ed, you are looking towards the moon, towards the top of the screen. And Red was looking for his observation.
So what you're saying here, what you're trying to confuse me even more, but come on. Let's have a go.
I'm putting it in the correct frame.
Right. So you're now saying, what are you saying here? Show me what you're saying. What are you saying here?
Red was looking due west. The moon be moving in relation to this view? Up or down? Left or right?
Red, you're saying Red is standing here and he's looking up here.
Which way would the moon be moving?
You're saying Red is looking here.
It was looking due west. Towards
the
moon.
West. The moon's up there, yeah?
Yes. Would it be moving in relation to the Earth at your feet?
So it's going to, the Earth will spin this way down to the east. What? So hold on. Okay, let's go with this then. The Earth is spinning down. You're saying that Red was looking. This doesn't make any sense because he wouldn't see that the moon would be behind the horizon at this point.
That's exactly the point. He was looking just before moonset.
No, the moon was high in the sky.
Red? No, not for Red.
Yeah, it was.
No, it was. It was fucking 4:40 in the morning.
Yeah, the moon was high in the sky, and that moon will still be there in the daytime. That kind of moon. What are you talking about? That moon doesn't go. That in fact, that moon wasn't even going anywhere really. It was moving, but you
So was
know,
it moving or wasn't it? Because now you've just said two different things about the same observation.
I
So
know that
which
was a
is
bit
it?
confusing because I
Is it
was.
not?
How do you explain that it's going to be there in the daytime? Hmm?
Because geometry is a thing.
You see, so look,
A
you see,
thing.
you've just confused me. I've just confused myself. Obviously, that moon is moving, but how is it there in the daytime? And you know, so obviously, then if it's there in the
So
daytime,
so so as
yeah,
Sean and Geo and I think some others have shown you, during Red's observation, lower in the sky, west.
but why have we
The
changed?
observation in
Yeah, but
Texas
hold
a
on, why have we
month
changed? Why?
later,
Go
a
on.
few days later. We're going from November 4th to December 7th.
Yeah,
Different location, and you are also moving your observation by over 1,500. Are changing
you're
the
breaking up
direction
there.
you are
You still
looking.
hear me? You still there? But what you're forgetting as
Are
well,
you fine?
that the ISS can only make this like this. So when it goes past the moon, red should have got it the other way diagonally, not that
No,
way
no.
diagonally. That was another
You
point.
are ignoring
Yes.
the ISS tracker that I showed up that showed the actual path, how it doesn't go beyond the poles. It oscillates back and forth.
Yeah. So it goes like gets to the top here, and then goes back down, gets to the south way, and then covers that
And then
area.
turns and goes back up. And
No, it doesn't turn. It stays in this orbit and then comes back
no, it
up.
doesn't turn.
Yes, it
I
would.
can
How would
bring
it? How would it
I can
turn?
bring the tracker back up. Back up. You do know
No,
that the ISS has engines and has motors on it to
no.
actually
Look,
boost its
let me just
altitude.
let me try to demonstrate what I mean. So let's just say we've turned this around. What color are we on? So the ISS goes from west to east, and then let's say it's gone around, then it comes back again, then it goes back again, goes around, and then when it gets to the top here, because it doesn't cover the North Pole, it goes around the top and then back around here again, back
Wow.
around, and then down again, down, down, and then covers that area again, and then back up, like so. Do you understand?
Yeah, it doesn't corkscrew like that though.
No, no, but I'm saying that's how it gets up and down the Earth. If it's a ball, that's how they try to tell us that. That's how it would cover the land. So it doesn't need to go. Obviously, look, you could
Yeah,
do it.
I think there are a vast number of people that would disagree with you
You
on
could
that
do the
right now.
same way if you want to go that way, right? So then it goes up there, down, back around, and then back up there, doing all the same thing. But then it would get to about the South Pole,
No,
go around.
it doesn't get
So then what's the how you're saying it? How do you say it goes around the board? So it goes around, back around.
and I will show you again.
Do it with paint. Okay.
Why do it in
No, no, no,
paint?
no, no,
I
no, no. Go to paint. Go to the no. Go to paint and show me around the ball how it moves. You doing it, yeah?
Hang on.
Because this is what I've been asking for
You're
the
you're
most. Is someone to show me how it goes around the ball. No, go, yeah.
patience, Padawan.
Sorry, I thought your screen was frozen.
Let's fill that in. Christmas.
Right, no, just for the sake of discussion, just do it straight. Yeah, you don't need to do it diagonally. Just keep it straight, as if it was. So
No,
we've
no.
turned.
This
Yeah, but no. Let's imagine we've
is
turned our
this is not.
heads.
No. Hang on. As close to reality as I can.
Okay, mark north and
Available
south,
to me.
east and west. Yeah.
That's what that is. That is the axis of rotation. So before you jump to any conclusions,
Yeah, two different directions.
no. So north, south pole,
Oh.
equator.
Yeah, but why? This is again, Jared. This is again. If you're not trying to be funny, you can make that for the sake of argument straight. You should be able to do it just as straight. Doesn't matter if it's a tilt or not. You should be able to demonstrate.
Being as accurate as possible. Because here's the thing.
Okay, go on. Let's try then.
Only goes up to about here. And as you notice, when it gets up to here, wait.
Yeah, use this one. Yeah, go back. Press the blue back. All right, go on. That's it. So you're saying
turns, goes back down, gets to a point, and turns again.
What? What is this?
The same thing that's shown here. Holy fucking shit!
That doesn't oh my god! I said this to Curved, and he says it doesn't do a sine wave. This is what
happens.
No,
yes, it does. This is really. Then why are people able to use this to track it to
go back
find
to your
when
paint.
they can
go
see
back
it
to your paint
and work?
Go back to your paint. Right, no, now show me the path on a board.
That you can only see half of it on a ball. And see, that's the thing what around here, and it starts going back up. It gets up to a similar point here on the other side, then goes back down, and there's such an oscillation that the next path here, it would actually come over here and then go back down, and then does it again and goes further off. And it loops around that way. There is a deviation to it. It doesn't follow the same exact path. It is off.
I want you to make a video about this, Jared, because this is absolutely.
This is broadcasting live, and I have more people behind me agreeing with what is actually being shown.
This is unbelievable. You've got it completely wrong.
No, that is completely what happens.
Well, I don't see any field rotation, anything to do with it. That's for sure.
Well, that's the thing. That's why I kept it simple. That's why I kept it at this, so field rotation wouldn't have to be accounted for, but it would still explain why Red saw it in one field of view, why Texas saw it in another. And there was a reason why for Red to see a lunar transit and then one. They will not be able to see a lunar transit at the same time because of the eccentricity of the orbit.
Right. Well, when they show on a board, that's not. They show a band going straight around.
A band that goes straight around,
yeah, like a hula hoop,
turns at the top and bottom. You match this. This is the actual path that the ISS is taking right now. See how each words this peak is off? They don't line up. That is the eccentricity of the orbit. That is why an observer in Florida and an observer in Texas will not see a lunar transit at the same time. This observation was November 4th. And Texas observation, oh, and he dropped and left. Yeah. Yes, Geist, rotation and the Earth's tilt is a factor. That's why I tried to draw it the way I did. Now let's see what he's saying now. Okay, that's why he ran. Wow, because he can't read the screen, he ran. Out fucking standing. Sorry, guys, I wasn't showing the screen, but to wrap up, just so you guys can see, when I drew it, I drew oscillation of the orbit. I ain't no fucking artist. But yeah, that was fun. Don't save. He ran because he didn't see the big yellow live up in the right-hand corner of his screen. Because he's an idiot that doesn't know how to read his screen, he ran away. After all this time. God, I love having two screens. It makes screen sharing so much easier. Correct, Toad. If the Earth was not in rotation, it would be a circle. But since we are rotating, there's that change. Plus the ISS will corrections as well. Oh, that was fun. Yes, Geist, that is why I'm laughing. It is hilarious, the things that Spurs doesn't understand. Though I do find it hilarious that he accepted used of a car going down the street with the two observers at relatively different positions for the path. But as soon as you put it as to something in orbit, yes, gotta love it. Who knows what Spurs thinks? But my dinner is waiting for me. This was fucking hilarious. I loved it. I enjoyed it. I do apologize for any audio issues. There's a situation going on that don't need to know about, but it will be corrected shortly, and then my internet will be back to the robustness that I loved before. But you guys enjoy. I will be around. You can catch me in Google Hangouts. You can catch me in Strike's Discord. Really want to get a hold of me. This is my main name channel. You can find me if you want to chat. Till then,